A gentle tap at a stoplight, a slightly crumpled front bumper. In a vacuum, this looks like a minor inconvenience. But this impact just retired the entire machine. The pristine interior, the intact glass, the massive lithium-ion battery, and all the energy required to build it, everything is heading straight to the scrapyard. A vehicle is legally declared a total loss the moment the estimated cost of repairing it crosses a specific NIC threshold set against its overall value. The insurance companies set that fraction, but the design teams dictate the actual repair cost. A written-off car rarely means a mechanic physically couldn't fix it. It means a complex, highly engineered object was forced into an early grave by a rigid set of hidden financial equations. That financial math is heavily audited in the violent reality of the testing lab. Organizations like Thatcham Research, Euro NCAP, and the IIHS maintain massive testing facilities to measure exactly how expensive an object is to put back together. This is strict engineering. They crash the car at low speeds, meticulously measure every single piece that deformed, and assign a precise dollar amount to the damage. That final calculated number is then published globally and permanently baked into the premium an owner pays every single year. These crash tests certainly evaluate human safety, but they also execute a ruthless, unavoidable financial audit of the vehicle's structural architecture. If we step back from the testing facility and strip away the exterior panels, we can look at the physical skeleton of the car to find something engineers call the damage stop. Looking at this simplified schematic of a car's chassis, traditional, highly repairable designs utilize a sacrificial zone. These are cheap, bolted components explicitly engineered to die in order to save the rest of the car. As an impact occurs, bumper beams and crash boxes crush inward. Bolt-on wings cleanly unbolt. All the destructive energy dissipates entirely before a single piece of the permanent structure behind them is ever touched. In these older architectures, the design team decided well in advance exactly which parts had permission to be destroyed. But modern manufacturing has introduced massive unified metal castings and permanent structural adhesives into that space. By removing the mechanical fasteners and welding those separate pieces into single solid blocks, the physical boundary separating a sacrificial part from a permanent one disappears. This line graph maps the trade-offs on the factory floor. Consolidating parts into huge castings and utilizing hot-formed boron steel drives the cost to build down rapidly, while simultaneously sending structural stiffness soaring. But watch what happens to the repair cost. You cannot cleanly section a giant casting with a saw, and you cannot uncure structural adhesive. If a modest impact reaches one of these permanent assemblies, the entire unit is ruined. When part consolidation swallows the crumple zone, the financial burden is transferred straight from the factory ledger to the owner's insurance policy. Efficiency in assembly doesn't eliminate the cost of a collision. It just delays it until the exact moment of impact, virtually guaranteeing the vehicle goes straight to the scrapyard. If we step back, away from the loud factory floor, we arrive in the quiet, unhurried space of the early concept design phase. The person who ends up paying the catastrophic repair bill is not in the room when the joining strategy and load paths are permanently frozen into the architecture. Repairability is completely invisible on a pristine digital render. You cannot look at a beautifully surfaced concept and tell whether a joint underneath is mechanically bolted or permanently bonded. This is exactly where Depix operates. They build tools to help design teams evaluate the lifelong consequences of those hidden structural boundaries long before any actual metal is cut. A car is rarely killed out on the highway. Its exact lifespan is quietly finalized by a line drawn on a screen, months before the first prototype even exists.